Yes, let's start the discussion. So in our previous lecture, we talked about chi-square, Pearson chi-square. We also talked about, okay, that was the one before the previous one. Oh, they are all previous. The one second to the last, talked about Pearson, um, likelihood ratio chi-square, Fisher exact test, corrected chi-square, and we talk about trend. Okay, the last lecture we talked about chi-square for trend and chi-square for test of goodness of fit. So we want to discuss McNemar chi-square and McNemar Bowker. That will be the last lecture on chi-square. So the McNemar is a very innovative method. It's simple, very logical. What it does is that the McNemar is only 2 by 2 table, you see. But McNemar Bowker can be 3 by 3, 4 by 4, 5 by 5, 6 by 6. Because why it is like that is because it's before and after. You categorize into, maybe if it is McNemar, A and B, 2 categories before. Then after, you categorize 2 categories. So you now cross-tabulate the before and the after. If the category is up to 3, that's all 4 or 5 or whatever, that is where we now talk about McNemar Bowker. It's an extension of McNemar. So if the category is 3, before you do 3, after it's going to be 3 also. So it's going to be 3 by 3. So it's not 3 by 3 like other chi-square we have done, where we have 2 variables. Still only one variable. It's only one variable here. We have 2 variables in that one. One will be along the exposure, while the other one will be along the outcome. Then here is the same variable, which you do before and after. You compare. Let's see the way it works. You compare proportion between 2 related groups. Repeated measure or pair observation. The meaning of related is repeated. For example, now, we are still going to talk about the repeated also in t-test. But in the context of chi-square, which is for categorical, to test categorical variable. So we are having 2 categories, yes or no, alive and dead or whatever. Imagine now if you say hypertension, hypertensive, no hypertensive. After measuring blood pressure, taking history, you can measure both systolic and diastolic. I also have the history of hypertension. You can come and conclude based on the history, systolic hypertension and diastolic, systolic blood pressure and diastolic blood pressure. You can conclude if somebody is hypertensive or not. So if you do that type, before you conclude, you'll be able to know what proportion are hypertensive, what proportion are not hypertensive. Of course, it add up to 100%. Now, maybe you now do something, you may not do anything, but you take the measurement again, you come to assess blood pressure again. Maybe after your intervention, you have already done something, you feel maybe the intervention will have improved the hypertension, yes, the blood pressure. In that situation, you come again and measure like the same, like the previous. You categorize to hypertensive and non-hypertensive. So example you see here now is the table below shows the hypertensive status of a group of adults before and after an intervention that involve lifestyle modification. Did the intervention significantly influence their hypertensive status? So hypertensive. So after assessment, now you see there are 200 of them. 200, you assess them. From there, you see out of the 200, 60 you can see along the. So the before now is along the row. The choreograph was convex. So you see the total 60 that are hypertensive. Out of 200, 60 were hypertensive. You see, non-hypertensive end of that node, 140, add up to 200. So after you have done your intervention, you assess again the same people. That's one thing when you say pair, repeated measure is the same thing. The meaning of pair is repeated or dependent group or related group. The reason that it's the same people is the same people. You won't bring another person because when you are entering it, you're going to say, okay, whatever you enter for Eunice this time, after is on the row. If Eunice is number 1, the after the result number 1 will be number 1 also beside it, another row beside it, another column beside it. So one row for each person. Before and after, you have to put the status there. So that's why you call it repeated or pair. But the word pair is a misnomer in the sense that when you say pair, people will be thinking maybe there are two groups you are playing. No, there are not two groups. They think there are two physical groups you pair. No, it's only one group. So it's not group you pair per se. It's your observation you pair. So the same group, you have already said this person is hypertensive. The same person later, you now say whether hypertensive or not, you measure it again. So it's the observation you pair. That is, you pair what was before and what is after. That's why the word I say misnomer. People will be thinking there are two groups. And they also use it for things that occur naturally in pair in the body, like breast, like leg, like hand, finger, teeth, eyes, ear, you know, left and right. Everything left and right. For example, high, intraocular pressure before. Instead of before and after, you can use it for naturally because one person has too high. So because it's in the same person, without before and after, you can measure and compare the volume or the pressure. You can compare anything you want to compare. But even without before and after, when you are comparing two naturally occurring organs, maybe the variable you are measuring is from those two naturally occurring organs in the same person. Now, so let's continue with this. So you can see after the same 200, 40 are hypertensive along the column now. Yes, the total under years is 40. So after the modification intervention, when they measure, they are now discovered that only 40 are hypertensive and 160 not hypertensive. Still double out to 200. It's the same people. So how does it work? What is the logic behind it? So they call something, let me come back. Where you will see that in the first diagram, I label green B and C. You will see B and C are the discordant cells. A and D are concordant cells. Concordant means that this person is hypertensive before, is still hypertensive after. Or this person is not hypertensive before, is still not hypertensive after. That is concordant. So it doesn't change. So that one you not get that. It's not part of your calculation. But what you are interested in is this discordant. The people that were hypertensive before and they became not hypertensive after. That's B. And the people that were not hypertensive before and they became hypertensive after. That is the C. Can you see now? So in this example now, 52 and 32 are the discordant. These 62 were hypertensive before. They now turned to no hypertensive. You will see that 8 were hypertensive will remain hypertensive. That 52 plus 8 add up to 60 that are hypertensive before. So you will see 32 were not hypertensive before. They became hypertensive after. So you see, you can see the people that were not hypertensive before remain not hypertensive, they are 108. When you see add the 108 to 32, give you 140. The same thing you had 8 to 32 give you 40, 52 to 108 give you 160. So it doesn't change anything. What we are interested in now is what changed. The logic behind it, the test now, is non-hypothesis usually say there's no difference. So the meaning of non-hypothesis no different in this situation is that the number of people that change from hypertensive to non-hypertensive is the same thing as the number of people that change from non-hypertensive to hypertensive. For instance, now, the discordant, because the first one is good as change from the attribute hypertensive to non-hypertensive, then the people that change from non-hypertensive to hypertensive, 52 and 32 now. So if non-hypothesis is true that there's no change, because yes, there's no change, intervention did not do anything. So forget about the what you have. We just see that the number that change from hypertensive to non-hypertensive will be equal to the number that change from non-hypertensive to hypertensive. That should it's like somebody 2 leg forward, 2 leg backward. You see the same place. So you can't travel 3 kilometers and travel 3 kilometers backward, the same. And that's what is the displacement? It's 0. There's no left, it's the original place. So that is the logic behind non-hypothesis here. Now, For us to now, how do you calculate? That it will be, of course, you know the value when no hypothesis is true is the expected value. So we are interested in the expected value for the two. And I've already given you the, so if they are now asked you, how do you calculate the expected value? The expected value is just, okay, you know what's changed. The total that changed is 32 and 52. Okay, now, anyway, let me crack it because I actually have a question in workshop. So you look at it now, you see that the total that change is 52 plus 32. Those total change. If actually the null hypothesis is true, each of them, those total value will be divided equally into 2. So 52 plus 32 will be 84, divided by 2, 42. So if null hypothesis were true, yes, hypothesis to null hypothesis will be 42. Null hypothesis to hypothesis will be 42. So that is the logic behind adding all the different changes, 32 plus 52 that change, you divide into 2. That is, all the changes should be equal among them. That is what, that will be the expected. So 42 and 42 now, for both sets is the expected value for the two sets. That's why we say I, B is equal to B plus C over 2, C is equal to B plus C over 2. So at the end of the day, when you slot it in, you know it's the same chi-square. Chi-square is sigma, addition of observed minus expected square over E, expected. And it's only the two sets you are calculating for. When you calculate it, it gives you this 4.761904619, approximately 4.762. That is the chi-square. Now, for you to know, is this value significant? You want to know what is the, before you can go and check where to check. If you want to check on the statistical, you must be able to know the degree of freedom. As you can see here, the degree of freedom is for McNemar and McNemar Bowker is k into k minus 1 all over 2. K here means the number of categories. In McNemar, the number of categories is usually 2. There are 2 categories. If in McNemar Bowker, it can be 3, it can be 4. That would be the k. So in this case, it's 2. You say 2 into 2 minus 1 over 2 will give you 1. So the degree of freedom for this 2 by 2, this McNemar is usually 1 now, because there are 2 categories. The degree of is usually 1. So the critical value for chi-square, the degree of freedom 1 at 0.05 level of significance is 3.84. You know, we have already checked it before. You know that. So and 4.762 is far higher than 3.84. So that is why chi-square of 4.762 is statistically significant. Now, this is where you can run it. This is where you can run it. You see, you know, we've already known that when you calculate all these statistics with hand, you cannot calculate the p-value with hand. Then this is where you can run it. You see under the analyze cross tab descriptive statistics cross tab where you do normal chi-square, the same place. Apart, you know, it's only chi-square for goodness of fit. I will usually go to what do I call it? We go to non-parametric test. But every other chi-square, equally this one is the cross tabulation under analyze descriptive statistics cross tabulation. The row, of course, the hypertensive before will be the row. After will be the column. It's only that this thing, okay, this is okay, it's called this picture I've taken. I will have drawn this thing. You see that if you see the two before and after, they are enter in parallel for number 1. So one here is coding. 1 is yes, 2 is 2. Now here I will advise you maybe I should not flood you too much information. If you are doing, if you watch the training, not workshop, if you watch the training on the YouTube, you're going to see where we run all this on that training. They are there on the YouTube also. On that training, we run it. Now we'll take our time, we'll ask people to share. You will see the logic behind it. So but just know that when we do that, so it will show you the same chi-square, all those of them. You don't need the normal chi-square. You see McNemar down. Can you see at the lower left in right corner? You see McNemar. If you are doing relatively, when you get there, all ratio is the same place. You click on risk. If you are doing kappa, you click on kappa. Anything that has to do with cross tabulation, they are all here. So here we are doing McNemar chi-square to create McNemar. So it will go and give us. You see that it will repeat the same table for us. Now, you see one thing with McNemar, no computer can calculate, as able to calculate it. But they give you the p-value. But you can calculate the McNemar chi-square with your hand. But the p-value, you cannot calculate, but the computer will give you the p-value. But when it comes to McNemar Bowker, as you are going to see, you can see that the computer will give you both the statistics and the p-value. So there's something I want to, I thought maybe I skip it there. So now there's an alternative way of calculating this one. You know, this is the one I explained to you here, that we got 4.762. So before I come also, there's an alternative way. So instead of this, McNemar is so simple. Knowing that it's only B and C, through say that are discord that you are using. So intelligent people, they have discovered over the years that if you just say that B minus C square over P plus C, it doesn't really matter which one you put first, which one is greater, because it's absolutely different. You know, well, I think you say minus. Yeah, even if you get minus, but since it's square, that numerator is square. Minus, you cancel minus. Minus will be local because it's square. B minus C, doesn't really matter which one is bigger, which one is smaller among them. The negative will cancel negative when you square it. B plus C. So B minus C squared over B plus C. Look at it. It gives you the same thing. It gives you the same 4 points. You don't need to waste time. Shortcut. So it gives you the same thing. And you see? Now, I don't know if there's any question before we proceed to McNemar Bowker. You see this McNemar, very funny. It's easy to calculate, but the computer cannot calculate McNemar. It only gives you p-value. You cannot calculate p-value. You know? So it's very simple. It's just for you to know, even you don't even need to know, even if somebody give it to you, they tabulate it. Once you know it, you just say B minus C square over B plus C. That's the chi-square. That's McNemar chi-square. You can go and now check under the degree of freedom statistical table. Or if you now run it with you run it, you see the p-value. But it will not give you the machine. The software will not give you. I don't even know the logic. God is so great. Simple thing. And no, so I've not seen. I've not seen. Either painful starter, even all this star card that we use hand to calculate on the computer, they don't calculate. They don't give you McNemar. Cannot calculate it. They give you the p-value. You can easily calculate it with your hand because it's simple, and you get the p-value from the machine, from the computer. Any question? Before we proceed. Any question? No question. Okay. Now, let's talk about McNemar Bowker. So it's the same thing. It's the same logic. I will not bother you with all these things. They are just theoretical, but to me, let me bet. I will still come back to this table, maybe for you to know something about permutation, combination, logic. So the logic they use is about combination, which we have already even discussed also. It's the same thing we actually discussed in binomial distribution. It's the same logic. It's the same, but they're not completely the same, but the same logic. But look at it. Let's start with the example. So it will make you understand rather than. So there's this table below shows the socioeconomic class set of a group of adults before and after COVID-19 pandemic. Did the pandemic significantly influence their socioeconomic status? You will see that they use the parameter they want to use to measure socioeconomic status. How they measure, they will ask questions, the weight index, and whatever. That one is not so. The issue is that they have already divided them into upper, middle, lower, and there are 300 people. And after pandemic, they did it again. They will get you. So the before is along the row, the after is along the column, as usual. So upper, middle, lower. Of course, you can see the upper for before is 35, middle 100, lower 165. After, the upper is 35, middle 100, the other 65, the total. You see that the total did not change. All those did not change, but the issue. Know there are some changes. It's possible some people have changed from what the middle is the cell, 9 cell, 3 by 3. Maybe I'll go and alter this because at the end of it, it's not significant. Maybe I'll go and alter this data so that it can be, though it doesn't really matter when change it, so that it can be significant. I just delete the data. Now, let's look at the way it works. Because the same thing, there are 3 discordant. There are 3 concordant. Who can tell me the 3 concordant cells? The value inside the 3 concordant cells. You can unmute. There are 3 concordant cells. You can tell me the value in the 3 concordant cells. So just for us to, so that can be interactive, small, a little. Nobody? We have 7 of you here. Nobody, what are the, we talk about concordance and discordance. That's what we talk about. It's the same thing here. They are saying that here now, there are 3 of the 9 sets. We are talking of those green. There are 3 of the 9 sets that are concordant. Who can tell me which of the 3? Give me the value of those 3 that are concordant. Okay, nobody. Okay, it's maybe people are cooking. Don't let me call name. You want to be my student now? I'll be calling you.
I don't.
We are here with you, sir.
Okay, upper. I think upper is concordant too. Abi?
No.
Before
there are 9 cells now. All those green cells that are value inside the 9. Which give me the 3 values that are concordant out of the 9. That's what I'm saying.
22. 36.
Yes.
And 15.
Yeah, you are right. I don't know why it's taking too long. Many people didn't understand. Let me go back to that. You don't understand. Let me go back to that simpler one first. McNemar. We have already said that. Okay, which one are concordance here now? Though I've already said it. Or let me go back to the first one. So look at the table below. Which value out of the 4 green are concordant?
The 2 green?
No, there are 9 green now, and there are 4 green. Which of them are concordance?
Please, C and B.
Give me the value. Concordance.
32 and 52.
No, 32 and 52. What's the meaning of concordant? What's the meaning of discordant? The meaning of concordance is that years before, years after. That's 8 and 108. No before and no after. 8 is years before, appertensive before, and appertensive order after. 108 is non-appertensive before, non-appertensive after. That is concordant, 8 and 108. You are looking at the direction of that. No, it's not that. So the 32 and 52, they are the discordant because that 52 was appertensive yes before and become non-appertensive no after. 32 was non-appertensive no before and become appertensive yes after. Can't you see? So 32 and 52 are discordant, and that's what we use. The concordant are 8 and 108. Is it clear now? This one, is it clear to people? Is it clear? I need chorus answer.
I understand it myself.
Any other person?
Yes.
Okay. So if you come here, it's not the direction of the calculator, but it doesn't deserve you. So in this one now, so which one? Upper, lower. No, you even missed it, sorry. It's 6, 36, and 93. I was even carried away because you first thought. So it's 6, 36, and 93. Can you see now? So 6 is concordant, upper before, upper after. 36 is concordant, middle before, middle after. 93 is concordant, lower before, lower after. Does it make sense? Who are still looking? Does it make sense?
Yes, sir.
Yes.
So if you remember, in the McNemar, I usually color the discordant because we are not interested in the concordant. So I look at it, the concordat I left it yellow, white rather, not colored. So all these things I did it for people to understand. So the one that are concordant, I color them. Those are the ones we want to use for calculation. The same thing, if you look at here now, and now, can you see? Look at the table. 636, 93, they are concordant. So we don't need them for anything. So the one that have the diagonal, you know, this one you have plenty that have the diagonal because it is not 2 by 2. If you have 4 by 4, it will be more than this. You are going to have 4 sets that have the diagonal. But here, there are 6 sets. You're going to, sorry, if it's 4 by 4, you're going to have 8 sets, 4 on each side that are of the diagonal. But in this case, we have 6, 3, 3 that are discordant. And I color code them also because so that you know the one that they are discordant together. 7 and 14 are discordant. No, middle before, middle after. And the green, 22 and 15 are discordant because lower before is lower and later become no, upper before, lower after, and the other one is lower before, upper after. Can you see? So the blue is 50 and 57. Can you see now? Now, there is something I want for you to know more about the logic. This table, what I did it for is, you know, we talk about the number of categories of the outcome. So in this example of just done is this example we are discussing is 3 categories. So I now give example of when you have 2 categories, which is McNemar. Then 3, 4, 5, as many as possible, they are for McNemar Bowker. The first column, number of categories, K. Then number of cells, K times K. You know, if the number of categories is 2, there will be 4 cells, 2 times 2. If there are 3, there will be 9 cells, 3 times 3. The same thing, 14 times 4, 4 times 14 will give you 16. 4 times, can you see the number of cells I will give you? It will be square of the category. You agree with that? The third column is number of concordant cells. So number of concordant cells is usually equal to the number of the category. If you look at it, the number of the category, the one they are put white. In this example we are looking at is 2. What I say it's 3. There are 3 cells. So because there are 3 categories. Even in McNemar, is 2 also. So because there are 2 categories. The number of discordant cells is going to be double the number of the categories or double the number of the concordant. Can you see that? So, but apart from McNemar, which will be 2, McNemar, number of this is 2. But anything after McNemar, once you have 3 categories and above, the number of discordant cells will double the number of category or the number of discordant cells. Can you see now? So, number of pair of discordant cells, pair now. No, we pair them. So when there are 2 cells that are discordant, it will be 1 pair. So the number of pair will be equal to the number of the categories still. Can you see? Number of these categories, sorry. It will go to be the when you divide the number of discordant into 2. You know, for example, now we say when we are in this one we are doing now, there are 6 discordant cells. Divide by 2, it gives you 3, 3 on one side, on both sides. The same thing, number of pair, when we have 8 discordant cells, 4, 4. So it's going to be, because we have 4, 4 on this side, multiplied by, no, this one is 3. Number of pair of discordant cells. Mistake here. This one should be 4. Anyway, just leave it. So now let's go to the next one. This one, you will not bother yourself. The logic behind is how do we come about the number of that discord? It's not yes. That is why you may not get it here. It's not just by looking at the table, you won't get it. That number of pair of discordant cells, you now use permutation. In how many ways can you pair n number of items? In how many ways can you pair n number of items? Can you see now? So of category, n number of categories. In many ways can you pair them? Can you see now? The number of the category will be the n. Then what you want to pair, the pair need 2. R is 2. So n factorial over n minus r factorial times R factorial. So it gives you the number of, so just leave it. So the degree of freedom also, we have already said, is number of D into D minus 1 into D minus 2 is in D into D minus 1. That is, yes, that's the, look at it, K into K minus 1 over 2. So I also calculated the number of degree of freedom for each of those number of categories here. Just this one is just a rough so that people get to know. But at the end of the day, if you use your computer, it will just run for you. Now, let's proceed. How do we calculate? You know that the first thing is for us to calculate the expected value. How do we calculate the expected value for each number or for each discordant cells? So you know that the first one are middle for 7 and 14. So if no hypothesis were true, 7 plus 14 divided by 2 will be what will be in both sets. So 7 plus 14 make it 21 divided by 2 is give you 10.5. So the expected value, second table now, can you see is 10.5 for both of them. The other pair of discordant, 22 and 15. When you have 22 and 15 together divided by 2, you give 80.5, 80.5. Now, when the last one is 50 and 57, when you add them together and divide by 2, it gives you 53.5, 53.5. So those are the expected value. If you feed in now, the number, if you look at the number of pair now is 6. A number of the chi-square is not number of the cell, rather the number of cell of the discordant cell is 6. So for each of the cell, you now calculate the chi-square. My observed minus expected square over expected. You do it. That will be the chi-square when you add it together. So the chi-square is 4.116. And the degree of freedom is 3. If you calculate it, d k minus into k minus 1 divided by 2 give you 3. Now, you will see that the critical value for chi-square at degree of 3, degree of freedom 3, 0.05 level of significance is 7.815. Therefore, chi-square of 4.166 is not statistically significant. Can you see now? Because if you look at it, is the critical value for that degree of freedom 7.8, and what we got is 4 point. So it's not. So you can. There's no difference in their socioeconomic status. So the COVID-19 has not changed their socioeconomic status. So, or look at what I put in budget. Instead of all these degree of freedom, they are shortcuts. Where you say 17 minus or 14 minus 17 square over 17 plus 14. 15 minus 22 square over 50 plus 22. 57 minus 50 square over 57 plus 50. No, that one will just say just the different square over the addition. Short, can you see short? It gives you the same answer. Exactly. So that is. So running it is the same thing. The same place, cross tabulation, you go and it give you, look at it. So for McNemar Bowker, it will give you 4, it will give you chi-square, also give you the p-value. So there's no, it's not like McNemar where there's no, the machine, the software does not calculate the McNemar, it can only give you the p-value. But here, for McNemar Bowker, it will give you both. So I think that's the end of the discussion on McNemar chi-square and McNemar Bowker. Any questions? This is very category. That is, you don't use that ordinary chi-square, Pearson chi-square. No, you use McNemar chi-square or McNemar Bowker, depending on how many categories we have. Any question? Any question? No question. Okay. It's a short one because I don't want us to start new. Well, we have finished this McNemar and chi-square. I don't want us to start t-test. The next one will go to t-test. I don't want us to start new discussion because it will, because that one is another concept. We first all bring it fresh. So the next lecture, Tuesday, I guess God's grace, we start our discussion on t-test. T-test will take us to t-test and non-parametric counterpart will take us maybe 2 lectures. T-test itself will take us 1. Non-parametric counterpart will take us another 1. Yeah, okay. Any question? Okay, there's no question.